Okay, this is the third video and hopefully the final video on example number 1. And here we are asked to explain how we would determine the pressure applied to a diver after 120 seconds of descent. So just based on how you would go ahead and problem solve, you would take a look at, well, I'm looking for the pressure, but what I'm given is a seconds. So if I take a look at the chart, I know that at 120 seconds, I have a depth of 90. And well, what does depth of 90 tell me? Take a look at the next chart. Depth of 90 tells me that there's 10 atmospheres of pressure. So now that I've solved this question, how do I write this in math notation? What did I just do? So first I looked at the first function or the first chart and I plugged in that given amount. So I plugged in 120 to figure out my depth, and then I realized when I plug in 120 I get 90 meters of depth, and then with 90 meters I took a look at my second chart, and my second chart was what tells me my pressure based on the depth. So I get pressure is equal to G of 90 meters, and that output is 10 atmospheres. Okay, so that is what I did. And that gives me to 10 atmospheres. You can also write this out in English first, but I want you to start thinking about function notation. Because in our next part, we're going to use function notation to represent part D. And that we've already done. But now we also have composition, right? Okay, so take a look. I'm going to go ahead and color code this for you. This 90 meters is what we plug into here. And that 90 meters is the output from this function f of 120. So essentially we're plugging into here. So we can go ahead and rewrite this scenario, this entire scenario here, as g of f of 120. Because that f of 120 is that 90 meters here. And this is what we get back out as 10 atmospheres. So now we've put two function evaluations together, we've composed them together. And that's called function notation. Function composition, sorry. Function composition. So if you were to take a look at this chart, if you were given, say, g of f of 120, and told to evaluate this, you would first go to the function f, plug in 120, see what you get back out, and whatever you get back out is what you plug into g. Okay, so that was confusing. Let me go ahead and give you another notation. If this is your function f, you want to plug in that 120, whatever you get back out is what you go ahead and plug into your function g. And then your final answer is that 10 atmospheres. So what we did was we looked at our first table, plugged in 120, figure out what we got back out, plug into our second function g. Okay. So describe the output from part E in context. Well, in part E, this is the atmosphere. So 10 atmosphere is the pressure at 120 seconds of descent. So by describing the output, I'm describing the output in terms of that first input. So we're tying this entire story together. Okay, and that is the end of example number 1.